All right. I think we are live. Hello, everyone. Thanks for tuning in to another Fluent live stream. I am Dino, one of the co-founders of Fluent, and then we're here with Dimitri, my co-founder and CTO, and David from Fuel. Welcome, David.
Hey guys, thanks for having me on.
Um, no, very, very excited to talk more about this. Would you maybe to kick this off, for those in our like audience not totally up to speed with Fuel, can you just talk through like what is Fuel Network and then maybe talk about some of the attributes of the Fuel VM since that'll be largely the focus of this conversation.
Yeah, so Fuel is a project building. I guess we'll say we're a project that set out to kind of scale Ethereum, and we're doing that by building kind of a next generation virtual machine and a full like operating system for rollups. And the core of that is the Fuel VM, which is a brand new virtual machine, specifically made for like Ethereum rollups and specifically made for high performance applications. It's yeah, we have a whole stack that goes along with it in terms of all sorts of tooling, SDKs, and a new language. Language is called Sway. So Sway is yeah, kind of a new application specific language that's kind of like a cross between Solidity and Rust, and that's the language kind of for building applications in the Fuel ecosystem.
Makes sense. So one thing for people who haven't yet tuned into VM Wars, a different podcast that I actually do with David as my co-host. So we talk a lot about VMs on there. So quick shell. But if you haven't tuned in, there's been a lot of talk about different types of VMs, next gen VMs over the past year, and like why they're actually interesting and in some cases like better or at least different than the EVM, which is for the most part been the execution environment people have spun on chains with so far. So David, like specifically like within the VM, like what attributes are most compelling to users? You mentioned like Sway as a programming languages, but what other elements?
Yeah, I think before I dive into that, I'll just kind of I just want to expand on what you were saying about the VM space in general. This is certainly something that, as you mentioned, we talk about a bunch on VM Wars, our other podcast. Um, but I think we're seeing kind of more of an growth of different types of virtual machines in the blockchain space. I guess do like a speed run through like the history of VMs. The first real VM in blockchains is like the Bitcoin, virtual machine, which is this like you can almost barely call it a virtual machine. It's this really lightweight, it's not non-Turing complete machine that just is designed to do the basic functionality needed for a Bitcoin transaction, which is like validate different types of like signatures, hashes, like just pieces of cryptography. And then, Ethereum came along and tried to kind of bring like a fully complete computing environment, a full virtual machine to blockchain. So, the goal was to be like, okay, it's just a generalized computer. But when you look at it, it's still pretty opinionated in some sense about what it's trying to do and what types of applications it's going to support. So some of these decisions are things like having 256-bit word sizes, which the idea there is like that kind of goes along with not having floating point numbers. We're saying we're doing financial applications. We can't have the non-determinism of floating point operations. We need, financial applications need a lot of precision. So we're going to have like really big numbers everywhere. So the VM makes design decisions like that. It makes decisions like having a native asset be part of the virtual machine. So like low level operation lets you like move ETH around, things like that. Um, and that was kind of like the virtual machine. And to some extent, that is still kind of like the dominant virtual machine in blockchain. But we're seeing like more and more virtual machines, a lot of them that are targeted towards something specific, and others that are trying to be more generalized. So on the generalized side, we're seeing more ecosystems using WASM, using RISC-V, MIPS, kind of like just taking existing virtual machines from kind of the web 2 or just like the general computing ecosystem and using those for blockchains. And then there's virtual machines like Starkware. Starknet is like the Cairo virtual machine is like a virtual machine optimized for Stark circuits, and Aztec has also like a ZK optimized virtual machine for privacy. And what we were trying to do with Fuel was to make a virtual machine not designed towards any specific technology, but one that's designed towards the use cases of blockchains. So um, generally blockchain applications are financial in nature. So we want things like native assets. We want to ensure that like the movement and transfer of assets is cheap, it's fast, it's easy and simple. Um, and yeah, we want performance to be very high. We've seen that like in blockchains, but also just in finance in general, performance matters a ton. Um, like Wall Street is constantly optimizing their systems to try to get like squeeze every little bit of latency out, every little bit of throughput out of, kind of their infrastructure. And we think that blockchains are always going to like have this need to be a little more performant, a little more, um, yeah, a little faster, a little more throughput. And I mean, I think like the success of things like Solana is kind of proving that out, that there's already kind of like a movement of some types of applications towards like higher performance VMs. Uh, we're trying to bring that movement towards Ethereum rollups, and to do it without making some of the trade-offs that VMs like, for example, Solana have made.
Makes a lot of sense. No, I appreciate kind of the walkthrough of kind of VM history
Okay.
and how that ties into Fuel's design decisions. Can Before we transition into the integration, can you talk a bit more about Sway? Like you mentioned, it's this like Solidity Rust hybrid, but what's the deal there? Like why do we need another programming language? Why would somebody go through kind of like that bootstrapping phase or learning curve of picking up Sway? I mean, you talked a little bit to that, but if you could expand.
Yeah, for sure. I mean, and on one hand, like my opinion has always been, people will learn the tools that they need to do to build the applications they need. So my goal at Fuel is to say like we want to build the best virtual machine, the best ecosystem, and if people can build applications on Fuel they can't build elsewhere, then they'll learn Sway. Because I know like I'm a Solidity developer myself. Like any programmer is going to say like learning a new language, even if it's a better language, is always a bit of a road bump. But that being said, we do think Sway is a great language. It's a language that's built for the types of applications that blockchains are used for. So I would kind of contrast this against a lot of ecosystems that are embracing, generally seem to be embracing Rust as like their blockchain language of the future. Some of them are using like JavaScript and things like that. But some blockchains seem to be moving towards using like legacy or traditional programming languages. And our take is that that's often like not the best solution. Blockchains are very specific types of applications. They have certain attributes. When you look at applications built in Rust, like there's a lot of kind of syntax, a lot of decorators and things that are needed to kind of make the language be conformed into a blockchain type language. And I think we've just seen throughout history when there's a new like computing paradigm that actually comes with new languages. We've seen, both Google and Apple build new languages for mobile. We've seen JavaScript emerge as the language for web. Even though like there's always some reference to the past. People didn't end up using Java for the web; they used JavaScript. And even though Android was originally built in Java, like they ended up. I actually don't remember the name of Google's new language, but there are often languages that are like better suited for the types of the new paradigms of computing. So the Sway language itself, it's meant to be very safe. Blockchains safety is a huge component of it. Building applications that are secure, that are predictable, that's a big component of it. And we've seen kind of some of the issues around Solidity, and we've tried to address a lot of those issues. It's meant to be very readable and flexible. So yeah, I'd say overall it's got a lot of the really nice attributes of something like Rust. It also, I'd say, doesn't have some of the complexities of a language like Rust. One of our opinions is that a lot of the Rust language is designed around memory safety, but in a way that allows you to be very conservative with your memory usage. And one of our takes is that that's not as much of an issue in blockchains, where blockchain execution is very I don't know if temporal is the right word. Transactions are executed for a brief moment of time and then they complete. That's true of other components of the blockchain stack too, things like indexers and whatnot. you don't need to be quite as cautious with like things like memory leaks because your applications, first of all, you're paying for these resources, and second of all, your application is going to finish running in a few milliseconds anyways. So those are some of the design decisions behind Sway.
Awesome. Yeah, I think if there's anything that like we feel strongly about, it's that, you know, you should be able to use kind of the best possible tool for what you're trying to accomplish. And I agree, like there's going to be, you know, I think you can argue for a lot of different applications. The design decisions that you made would be like useful, and so like on one hand we completely agree that if there's enough of a reason for somebody to learn some new language, like they'll do it. Like you mentioned some examples, like it's a thing, like it's fine. So like we would never want to take the stand like against that, but at the same time, I think that there's certainly value in like just bringing like more tools into the sandbox that already exist, be it like other programming languages that are already that you already know, or like other libraries that come with those programming languages. And so like if there's something that we're, you know, we feel strongly about at Fluent, it's that, you know, blending these things together ends up leading to better products.
Yeah,
And that, oh yeah, go ahead.
I just wanted to jump in and say like we totally agree with that, and I'd say like Fuel in some sense is somewhat opinionated in terms of the architecture we're building and the types of applications we think it's well suited for, and that's why I think it fits nicely into kind of the Fluent sandbox that, you know, again, in some sense we're optimized for like high performance, you know, DeFi applications and things like that. I think we all believe like the blockchain ecosystem will expand beyond just like the DeFi apps that we're seeing today. And there will probably be other virtual machines that are better suited for those type of applications or better suited for the development of different types of applications. So, um, you know, again, we think Fuel is great. We do want to expand the scope and we do want to take on as much that we can. But I think it is like, I think we would agree on that. Like, it's important to have different tools for different applications. And that's one reason that I'm excited about Fluent is it's taking things like the Fuel virtual machine, like some of the really great technology we've built, and allowing it to kind of be live in the same ecosystem as some other really great technologies as well.
Yeah, and actually, if we can, before we segue into the integration, a little bit about blended execution as a design, where Dimitri can unpack like the integration as well. Maybe if you could just say a little bit more around like why you guys are excited for FuelVM to expand into other ecosystems, right? This is something you and I have talked about a bit before we even set off in this integration. And I think there's a general kind of very positive some sentiment across the industry of folks like developing new VMs of like, hey, like I want to spread this thing all over the place. And it makes sense intuitively, but I'd be curious to hear more about why.
I mean, at a basic level, it's just we're excited about the technology we built. You know, Fuel will be coming. We'll be launching our first roll up in the next couple months, and we're excited to see applications built there. But you know, this is open source technology. We want it to be used everywhere. We want people who find it useful to be able to use it in whatever context that they want. So we're excited to see other rollups built on the Fuel stack. We're excited to see rollups that specifically integrate the Fuel VM like you guys are doing at Fluent. We're also excited to see Sway kind of potentially living outside the Fuel VM. We've seen, I guess I've mentioned, you know, there's a number of ecosystems that are building new VMs but are relying on languages like Rust or other kind of existing languages. We think there's really awesome opportunities there to introduce like a really nice modern blockchain specific language of Sway. So yeah, again, we think Sway is like it is in our mind like the blockchain language, and we want that to be used wherever there's like cool blockchain applications. And the further we can spread it, like we just want to build the community around these tools and around these pieces of infrastructure. Um, and that just benefits everybody. So the more chains are using the Fuel VM and the more chains are using Sway, the more we're going to see tooling built, libraries built for Sway, uh, resources for developers to learn these types of things. So that's obviously the more the merrier when it comes to kind of using this tech.
That makes a ton of sense. I mean, we definitely resonate with that ethos too. Like one thing that we try to make really, really clear because we, you know, when people hear the blended execution thing, you say, oh, well, you know, you can basically run all of these different apps from different ecosystems in one place, and like they like a common question is like, oh, well, do you see that just like eating everybody's lunch? And the answer is like, no, like we're not. That's not our ethos. Like we definitely see just like blended execution as like a really interesting way to design any given sandbox. And like and that actually is why we're building the framework along the way of our RL2 that we're launching at Fluent Labs, because we do see like the need to have like a bunch of execution environments, and we would hope a lot of those would be blended and choose a bunch of different between a bunch of different design decisions, including like incorporating the Fuel VM and all of its glory. So maybe we can use this as a segue to talk a little bit about blended execution and this integration itself. So Dimitri, do you want to give a bit of an introduction to blended execution? Maybe we can then talk about the Fuel VM and what is being enabled, and just generally like how we're thinking about extensibility of Fluent.
Sure. So, Fluent blends. What does it mean? Blended execution. So, blended execution is the way how we represent the transition function, so-called transition function. We blend everything, starting from WebAssembly, because we blend WebAssembly inside itself and represent it using our intermediate representation called RWASM reduced WebAssembly. And this is how we represent all execution environment simulation. And this is how we represent, for example, virtual machine translation stages. And this is how we run and execute all applications on the same state without any additional modifications. So for Fluent itself, it doesn't matter what execution environment to run. We call it execution environment. For example, EVM. I don't think that EVM is a virtual machine. Even if it has a Ethereum virtual machine inside its name. But EVM is a context-dependent execution environment that runs inside Ethereum, like execution environment and the Ethereum ecosystem, because it has a context dependency. So if you run EVM, you can just ignore most of instructions and say, oh, we don't care about these context-dependent instructions. We just support EVM transition, and that's it. So Fluent supports execution environments. Fluent can support virtual machines and bring support of different languages, binary formats, but also Fluent supports execution environments, including all standards, all like the potential state dependencies, etc. So this is how Fluent can represent everything. And to support these environments, of course, we develop special simulation toolset. We call it simulation because simulation sounds more reasonable compared to emulation, because it's not an emulation, because we simulate standards. This is why we call it simulation. We run special simulation software like executors, loaders, deployers that are used to make software and execution environment feels that it persists in the same execution environment originally. So if application is developed for EVM, for SVM, for FuelVM, it 100% shows that it persists and executes inside the same network for what it was originally developed and designed. This is the main concept. It removes all potential bottlenecks for developers to migrate the existing software, to integrate with Fluent, because they just can use their favorite tool set, their favorite RPC provider, their favorite, I don't know, block explorers, blockchain wallets, and all these tool set are automatically compatible with Fluent, with all execution environments that Fluent runs. So regarding implementation of FuelVM, FuelVM is a bit tricky because FuelVM has two different execution environments inside, two different simulations. The first one is runtime simulation itself that executes using WebAssembly, and the second is FuelVM execution for user-specific applications. But for Fluent, it makes no sense how many execution languages, how many execution runtimes you have inside, because we just create simulation software, we just translate everything to our representation and store inside our tree. This is how we run, and we call it blend because it's literally a blender where you put all your applications, software, execution environments, virtual machines, no matter what you put inside, and then we blend it and produce one final state transition function. And the concept is that We are planning to make this process fully permissionless, and developers will be able to integrate and create their own execution environments, because like if you can simulate WebAssembly, then using WebAssembly you can, I mean, simulate. By simulation I mean um, creating state transition. If you can do a state transition for WebAssembly, using WebAssembly you can represent EVM, you can represent SVM, you can represent FuelVM, and etc. You can also simulate runtime of these virtual machines, of these execution environments as well. So then you can, for example, you can run simulation of anything. You can literally put, I don't know, Windows XP inside and run. Yes, it's quite useless goal, and we don't suggest developers to do this, but it's what you can do and what you can achieve. Yeah, so this is the basic like definition of concept of blended execution.
Just want to jump in real quick. This is something that we haven't admittedly talked about enough, just like everything related to the extensibility of blended execution environments. A lot of other people are trying to support multiple different like VMs in their execution environment, and it's done in a way where it's hard to add additional VM support, and even to the extent that you can, it becomes very inefficient to ZK proof. So Dimitri, could you talk a little bit more about that? Like, why is this so extensible and efficient to extend?
So why it's so extensible? Because if you can transit like WebAssembly, you can transit VM, etc. You can transit whatever you want. And if you want transit whatever you want, you can also transit a software for developing transitions. The same concept. So you can create, we are developing right now an SDK for developers where they can define their own execution environments, transition functions that specify how these environments modify state, how they modify accounts, how they modify, for example, storage layout. And since there are two giant tricky questions, the first thing is storage isolation. It is supported by default, of course, but account isolation is not supported, and we don't do account isolation because for account isolation, for accounts, we allow developers, even if they persist in different execution environments, we allow them to do native on-chain interaction between these different execution environments by doing address translation system, by doing address translation using our special libraries. And this is tricky because in this case, we need to do some sort of trusted verification of correctness of all the state and account transitions. Such software is under development, and we're planning to make it permissionless as soon as it's possible and let developers start to blend everything inside Fluent, and they will be able to enable their own virtual machines, their own execution environments, etc.
Yeah, so there's one thing that we touched on a little bit, and the can you let's just unpack it a little bit more. So when you say it could be made permissionless, do we envision people, in a permissionless way, basically uploading more their own kind of VM support to our Fluent L2? Or are you just talking about like the VM itself and the framework if they want to create their own L2s or L3s?
So I'm more talking about how to enable more execution environments inside Fluent. Like if they want to blend more VMs to add support of their like own languages or some custom languages, then they are able to bring these virtual machines inside. Of course, like it's more like a trusted. Of course, it's trustless, but it's semi-trusted because it's nice to do pre-audition of this code base. And for developers, for third-party developers, it's sometimes maybe unlikely to interact with this software directly. But the same actually happens with Solidity smart contract, because I don't think you're supposed to take a random smart contract address and who sent your money on this address, and expect that there is no vulnerabilities, they're not hackers, and they're not going to steal your funds. Of course, you check correctness of audition, you check correctness of bytecode verification, you do some sort of social network analysis of this application, etc., and also how it's trusted by the community. And we're also ready to help developers to create their own execution environments and to integrate them directly to be published like under Fluent name as a verified or fully audited, trusted. By trusted, I mean like by that it's verified and audited already. It's not fully trustless.
Yep. So it's both, and this is something that we only it took a little bit for us to land on, because previously we had just talked about it being supported in Fluent base. Like we always wanted to add new VM targets for people to kind of spin up their own chains with and make a bunch of different trade-offs depending on their needs or what applications they want to support or what like developers they want to focus on. But it's been pretty cool for even for me to kind of like learn that it will be feasible for to make like the L2 itself permissionless to add VMs to. So just wanted to add some clarification there. So let's see, David, do you think I want to zoom out for a quick sec and just talk broadly about the innovation happening like at the execution layer and kind of how you guys are positioning yourself. And I know we've we've talked about this plenty offline, and you shed a little bit of light on it, but can you talk a little bit more about how you guys see things? I know you have mainnet coming up. Yeah, give us a scoop.
Yeah, so as you mentioned, our mainnet's coming up in, yeah, just I don't think we've released a date yet, but in a couple months. If anyone wants to kind of start preparing for our mainnet to go live, we have launched a pre-deposit program last week, and I mean, I'm looking at this mainnet launch. This is just the beginning of our journey. I think kind of the goal of this is to, put the Fuel virtual machine out into the world, get applications that are being built on it, to production with real money in it, start kind of proving out or showing the world what we can do with the Fuel VM. But we have like a ton of other kind of really interesting things in our roadmap to bring to the Fuel virtual machine, to the Fuel ecosystem in general. And we're just trying to solve for a lot of the big issues that are facing blockchains these days, and a lot of issues that like can sometimes be really hard to tackle if you don't have integration across the stack a lot. So, the fact that we have our own virtual machine and a language and a lot of the tooling, and even more components in the future means that we'll be able to tackle a lot of the really hard problems. One of the big issues we're looking to tackle right now, one of the kind of main issues with the Fuel's tackling in general, is the issue of state growth. I think we're seeing more and more people talk about that in blockchains, that we've solved the data availability constraint with things like EIP 4844 and with other DA layers like Celestia. There's a lot that's being done to address execution. That's Fuel itself. We've spent years building like a really execution optimized virtual machine, and we've also seen a lot of other great projects in the ecosystem using building optimized virtual machines, using things like ZK to allow for improved execution. And now state's kind of the issue everyone's tackling. We've got some really interesting techniques already to address state. Like we have a key primitive called predicates in Fuel, which are kind of like stateless smart accounts. They power general account abstraction in general, and they also can be used to power like DeFi applications. So that's kind of one way we're addressing it now. We've also got like a lot of other really cool ideas to address state that'll come in future releases. So yeah, we're just excited to kind of get the VM out in the world, to bring it out, probably first with the launch of Fuel Ignition, our first rollup. But we're also, again, super stoked to see the Fuel VM being integrated into Fluent, and to see kind of what this VM will look like when it's blended together with other VMs. Yeah, and I think this is just the start of kind of like the next iteration of making blockchains more efficient, more well-tuned for the types of applications that are being built on them.
Oh yeah, man. Dimitri, Are there any other aspects of this integration you want to talk to? I don't know if we have an exact like timeline. We're working on it right now, but I don't know exactly what I might have missed that you're very excited about. We've talked about state growth. We've talked about supporting Sway. Any other things you want to share before we wrap?
So integration of each execution environment is sometimes a bit tricky because you need to figure out a way how to represent information in a bit different manner, how to represent the state, and sometimes there are several restrictions we have. For example, we it's highly recommended, for example, to support strict access lists in the integration to be integrated into Fluent, because otherwise the integration might be sometimes suboptimal. Also, it makes it partially incompatible with parallelization model that we might integrate in the future. But if we talk about the most exciting things, I think we're right now on the extremely right way to achieve the right structure of our SDK and to formalize the final vision of our APIs, how to integrate. Because like all VMs we integrate right now, they're super different in terms of how they proceed transactions, how they execute VMs. Like FuelVM, they uses UTXO-based models with different transaction types. For example, Solana uses this account-dependent account dependency model with modified storage layout that is compatible with original like EVM compatible storage layout. And all these VMs were very excited to integrate because they're very challenging to combine them together. And yeah, so this is the most exciting thing.
Nice. Yeah. Let me pull out some stuff that I'm excited about. So like let's look from like a developer and user experience. Let's talk about developers first. Um, do, will this work like our kind of like our Rust and Solidity blended apps where let's just say you want to design something in using Sway, and another part of that, I'll say like experience, like it could be across a bunch of different smart contracts, but that another part of that experience might be in Solidity. Um, the current demo that we have, that chess game demo that uses Rust and Solidity, the Rust is just completely behind the scenes. Um, so Dimitri, do you see this working in a similar way? Like, will users with their maybe EVM compatible wallet be able to use an app that potentially has just like Sway powering like parts of it behind the scenes, but they're not necessarily exposed to it directly. It's just like either an app that couldn't have otherwise existed, or maybe an app that's just that much more performant than if it was implemented in some other way.
Yeah, so this is so you have just described the concept of
Okay.
let's
Well, it's important. It's important to like like I think it's always really important to ground people in just like a concrete understanding of like what their experience is going to be. So it's nice to kind of show builders like, hey, like this is how you're going to interact with it, and then users how you're not going to interact with something because they shouldn't always have to care. So yeah, if that's correct, that's what I'm most excited about, how it can just power things behind the scenes. But I don't want to steal your thunder there if you're going to say something.
Yeah. So Fluent doesn't want to break existing developer experience, but we want to expand developer experience. So we want to keep full compatibility with all existing tool sets, but at the same time expand it with more and more functionality. And one of benefits developers Jane is now they can do like native interop between different apps. So for example, developer can call FuelVM app using MetaMask wallet. That is originally sounds like impossible because they runs different execution environments. But technically, in terms of Fluent, it's possible because everything runs in the same execution environment. So, and developers now they can build apps that runs on the edge between these different execution environments. If we talk only about, yeah, you mentioned our chess game puzzle. So it uses WebAssembly to expand Solidity functionality, where Solidity is limited. We can use WebAssembly to bring more functionality, to create more precompiles, to use existing Rust-based libraries and integrate them directly into your Solidity application. Of course, you can also create application fully Solidity compatible, but sometimes maybe Solidity easier for developers. For example, maybe they want to use Viper for this. Maybe they want to migrate the existing applications and expand functionality. Why not? So all these options are possible, and the developers can create any application they want. And with support of SVM apps, or FuelVM apps, with EVM apps, developers can start creating applications that combine all these different execution environments in the same place and build something like Uniswap that trade assets across different execution environments at the same time.
Love it. Okay, cool. Any other? I think we can wrap up. Any closing thoughts, David, or whether it's about this integration, whether it's even just about Fuel, like what, where, what's I'll give you a quick like call to action time or any kind of parting words.
Yeah, I don't think I have too much to add. Again, I'm stoked to see this come together. Stoked just to see in general. I think this is part of like the cool thing about the modular space is like seeing a lot of different projects come together, like projects that are specializing in certain areas and other projects that can kind of leverage each other. So, we're building a VM. You guys are building like an awesome stack for blended execution. We're all building on top of Ethereum. We're all like, kind of going to be integrating in more ways. So really cool to see those collaborations. I think it makes everybody a bit stronger. And yeah, as I said before, I guess call to action if you're interested in building on the Fuel VM, you can go to docs.fuel.network. And yeah, we have a pre-deposit program that just went live. So if you guys want to throw a couple bucks in and start earning some points ahead of the chain launching, you can go do that as well. And yeah, I think that's it. Thank you guys so much for having me on to chat.
Love it, man. Go check them out. Come jam on our DevNet. It's now public as well. If you want to play around with currently Rust and Solidity, blending Rust and Solidity soon. Adding Sway in the mix as well. So yeah, thank you everybody for tuning in. David, pleasure as always.
Awesome. Yeah, I'll add also I'm stoked to build my first blended app. I've obviously been building on Sway for a while, but before that, a lot of Rust, a lot of Solidity. So I think it's going to be super cool to like put all those pieces together.
Let's build some kick-ass apps, man. Sounds good. All right. Thank you, everyone.
Take care, guys.
Thanks.